We're starting day 2 of the sum and difference formulas. Yesterday, last class rather, we learned about finding the sine and cosine tangent of angles that were not our typical common angles. But today we're going to do the same sort of thing, except we're not even going to be given some of the information that you were given before. We're not going to be using common angles at all. We're going to be using triangles and finding sines and cosines from that, but we're going to use the same formula. So get out your formula sheet. You'll be able to use that today with your sum and difference formulas on there. And the first thing you're going to do when you do these problems, we'll just go through the mechanics of it, and then we'll do one or two. So the first thing you'll do is you'll draw a reference triangle for the two angles in the inappropriate quadrants, so that like we've done in things past. I'm going to make this a little bit bigger so that you can see it better. Then you label the two sides using SOHCAHTOA. So the sides. And then you'll find the missing side by using the Pythagorean theorem, as you have done in the past. Okay, so here we go. Find the exact value of the trig function. If you're given that the sine of the first angle, alpha, is between 0 and pi over 2, that means it's in the first quadrant. And the cosine of beta is negative 3/5, and it's in quadrant quadrant 2, between pi over 2 and pi. Hello. So this is angle alpha. We'll draw the reference triangle as we've suggested you do in quadrant 1, and you're given that the sine of alpha, this is alpha, the angle, is 5 over 13, so 5, 13. So this is a common triangle, the 5, 12, 13. So the first thing you'll do is find the sine, cosine, and tangent for that angle, because you're going to be using it in the formulas that we're going to be using below. So 5 13ths you're given. Twist is 12 13ths, and the tangent is 5 12ths. Okay, now let's find beta. They say it's in quadrant 2. That's helpful. And so we'll draw the reference triangle in quadrant 2. Here's beta right there. Cosine is negative 3/5, so negative 3, 5, and this is a 3, 4, 5 triangle. We'll find the sine, cosine, and tangent of beta, as we've done before with our common angles. Sine is 4/5, cosine is given to you at negative 3/5 in the second quadrant, and the tan is negative also in the second quadrant, 4/3. Okay, so we're going to use our formula. We're going to write it out. That's always a good idea so that you know where to go. So this is alpha, this is beta. Cosine of alpha for cosine alpha minus beta, cosine of alpha, cosine beta, plus, because of their opposite signs, sine alpha, sine beta. And then you're going to fill in. So we get 12 13ths times negative 3/5, and we're going to add 5 13ths. I'm just looking up here at the angles that the values I've been given, or I figured out earlier, times 4/5. When we simplify that, multiply, we get negative 36 over 65 plus 20 over 65. I'm going to write it as one fraction. Negative 36 plus 20 over 65. That's actually negative 16 over 65. So there it is. Okay, let's do the sum of the sine. And first, we'll start out with sine of alpha, cosine beta, writing the formula, plus cosine alpha, sine beta. And then we'll look at the triangles again. I'll make this a little smaller so we can see them on the same picture. And we'll fill in 5/13 times negative 3/5, which is a cosine of beta, plus 12/13, which is cosine of alpha, and times 4/5, the sine of beta. And it looks like we have the same same denominators, 65. Numerator, 5 times negative 3 is negative 15, and over 65, plus 12 times 4 is 48 over 65. So we add those together, and we get 33 over the common denominator, 65. And then we'll do tan, which is a little bit different formula. So tan of alpha, subtraction, minus tan of beta, over 1 plus the tan of alpha, tan of beta. And again, you can use your formula sheets to do this. And we'll just substitute tan of alpha as 5, if you look up here, 5/12, minus the tan of beta, negative 4/3, over 1 plus the formula 5/12 times negative 4/3. Okay, now we look at all the denominator. We got a bunch of. We'll simplify this a little bit. So it's 5/12 plus 4/3 over 1 minus, because of the negative, 5 times negative 4, so negative 20 over 36. Okay, so we could simplify that. I'm not going to bother. We're just going to go ahead and multiply the numerator and the denominator by the common denominator for 12, 3, and 36, which is 36. So we'll multiply numerator and denominator. So I'm going to multiply 5/12 times 36. And when I do that, it's 36 over 1. The 12s cancel with the 36, and it leaves 3 here. So I'm going to write that 3 times 5 plus, here I'm multiplying it times 36 over 1. So the 36 cancels with the 3 and leaves 12 there. So that's 48. 4 times 12, which is 48. Over, and multiplying here, 36 times 1 is 36, minus, and then here the 36 is canceled, and you minus 20. So you end up with 45 15 plus 48, so we get 63 over 36 minus 20, which is 16. No common factors, so we'll just, there it is. Okay. And so then we go to the next page, and we do the same sort of thing. We're given a little bit different, triangles, but basically we're doing the same thing. I'll move this a little bit so that we can see better. Okay. And we're going to find the exact value of the trig function that has this as the tan, and in quadrant 3 it looks like. So we're going to draw the two reference triangles. So I'll draw the first one in quadrant 3. And it has tan of alpha is positive 1/2, but we know that both the sides in the third quadrant are going to be negative. So we'll go ahead and I'm going to focus this just a little bit and see if we can get it a little bit better. That's not good. Okay, that should do it. Okay, and so we've got 1/2. So here's alpha right there. So this, we're going to label this one's alpha, and the tan is opposite over adjacent. So it's 1 over 2, except we know that they're both negative in this quadrant. And then we use the Pythagorean theorem. 1 squared plus 2 squared, or negative 2 squared, is equal to 5. Okay. And so we're going to take the square root of 5 is the hypotenuse. Okay, now we're going to find the sine, cosine, and tangent of alpha. So sine of alpha, cosine, tan, and we get, and you don't have to rationalize yet, so negative 1 over the square root of 5, negative 2 over the square root of 5, and then we were given the tan, so that's 1/2. Okay, now we're going to do beta. Okay. And that's in quadrant. It says it's negative 4/5 between negative pi over 2 and 0. So that's actually in quadrant 4. So we'll draw it in quadrant 4. And the sine of that angle is negative 4/5. So that means opposite over hypotenuse. And so this is 3. It's a 3, 4, 5 triangle. And we'll find the sine of beta, cosine of beta, and tan of beta. And that's negative 4/5, opposite over hypotenuse. Cosine is 3/5, adjacent over hypotenuse. And then the tan is negative 4/3, opposite over adjacent. So here we're going to use these three and do these. So I'm going to put the formula, sine, make it a little bigger. You've got those numbers in front of you, I think, so you can see them. Sine of alpha, cosine beta, minus cosine alpha sine beta. Okay, and then we'll just start subbing in, substituting negative 1 over square root of 5 times 3/5 minus okay, and then this, we're going to simplify this. We're going to multiply the numerators. So we'll get negative 3 over the denominator, which is 5 square root of 5, minus from there, and then negative 2 times negative 4 is positive 8 over 5 square roots of 5. And so we get negative 3 minus 8, which is negative 11 over 5 square root of 5. Now we rationalize by multiplying square root of 5 over square root of 5. Again, as we're going through the video, you can stop it at any time to write things down that you need to do so that you can keep up. Don't just let it get past you. You can stop. Okay, let's do cosine. Cosine formula first. Cosine alpha, cosine beta, minus, because it's plus alpha plus beta, sine alpha, sine beta, and we'll fill in the blanks. Cosine alpha, just looking up at your values that we've already figured out. So negative 2 over the square root of 5 times 3/5 minus, I'm going to put that in parentheses because it's a negative sine over alpha, so negative 1 over the square root of 5 times negative 4/5. We simplify that again. So that's negative 6. Negative 2 times 3, so negative 6 over 5, square roots of 5, minus, and this is negative times negative, so that'll be plus, so it's actually minus here, so 4, 1 times 4, over 5 square roots of 5, which is negative 6 minus 4, that'll be negative 10 over 5 square roots of 5. We can cancel, that becomes negative 2. So we have negative 2 over the square root of 5. Rationalizing that. Final answer, negative 2. Square root of 5 over 5. Okay. And then we'll do the tan formula. So that's tan of alpha plus tan of beta over 1 minus 10 alpha times 10 beta. Okay, and that gives us, so looking up at your table, up at your angles, the sines and cosines, we're just looking at the tan, which is down at the bottom. So tan of alpha plus negative 4/3, I'm going to put that in parentheses, over 1 minus, and then these two numbers, 1/2 times negative 4/3. Let's simplify that a little bit. So we get 1/2 minus 4/3, just so that it's easier to find the common denominator. And then 1 negative times a negative plus 1 times 4 over 6. Common denominator is 6. I hope you can see that. 2, 3, and then 6. So we're going to multiply by 6. By 6 over 1, if that helps. And I'm going to multiply this fraction, same 6 over 1, this one by 6 over 1. Okay, so 6 over 1 times 1/2. The 2 cancels. And we're left with 3 in the numerator right here. Minus, now we're going to cancel here. Left with 2. So it's minus 4 times 2, which is 8. Pretty complicated fraction here. It's going to end up being really simple. 3 minus 8 over, multiplying 6 times 1 is just 6, and then this 6 cancels, and we have 4, so plus 4. So you end up with negative 5 over 10, which is negative 1/2. Okay. Now, one more problem, and it's presented just a little bit differently. So we'll look at it. Its cosine of the angle is theta is equal 1/4, and it's in quadrant 4, they're telling you. So we'll go ahead and draw that triangle in quadrant 4. And they tell us that the cosine is 1/4. So here's theta. 1 over 4 is the cosine. And this one, when we 16, c squared 16 equals 1 squared plus the question mark. We don't know what that is. So it'll be 16 minus 1, so 15 is equal to question mark squared. So this side is the square root of 15, but it's negative because the y is negative in the fourth quadrant. Okay, so now we need the sine, cosine, and tangent. So we'll put them over here. Sine, theta, cosine, theta, tan theta. And the sine of theta is negative square root 15 over 4. Cosine is 1/4. They gave us that. And then the tan is negative square root of 15 over 1. So just negative square root of 15. And then we can find the sine, cosine, and tangent. But here they're going, so theta is one angle, but they're giving us a common angle here. So pi over 6 is beta. So beta will be, this is alpha. I like that. In color. Alpha, and this is beta. And so we'll let the sine of pi over 6 is going to equal, we need sine and cosine for this, is 1/2, as you know, and the sine of, cosine of pi over 6 is square root of 3 over 2. So we've got what we need. We've got these, and we've got this. So we're going to write the sine formula, sine alpha, cosine beta, minus cosine alpha, sine beta. Okay, and then we fill in. Sine alpha is 1/2. Actually, alpha is over here, so I'm going to fix that. This is alpha. I was calling it theta, but it is. But the actual alpha, so is this one, and this is beta over here. So sine alpha is negative square root of 15 over 4 times cosine beta. So over here, square root of 3 over 2. You can just fill in, instead of beta and alpha and all, you can just put in pi over 6, and here you could just put in theta. It's okay. Then the cosine of this bunch of angles, 1/4, times the sine of beta, which is square root of 3 over 2. I know it is 1/2. Looking at the wrong thing. Okay, and then we multiply. Negative square root of 15 over times the square root of 30 of 3 is the square root of 45. We can simplify that. There's a perfect square in there. Over 8. It's negative. Minus 1 over 8. Okay, so 45 is 9 times 5. So the square root of 9 is 3. So this is negative 3 times the square root of 5 over 8. Minus 1, and both of them are over 8. Okay, and why don't you stop the video and see if you can do cosine. I'll do it, and then you can turn it back on and see if you got it right. Okay, did you get it right? Okay, good. I hope so. And then finally, tan. And again, the tan formula. So I'm using the angle names theta, and we subtraction. So tan of pi over 4. What's the tan of pi over 4? You remember? Okay, so it's 1, of course, and then the tan of theta we figured out a minute ago was up here, negative the square root of 15 minus 1 over 1 minus the two things multiplied together. So negative square root of 15 times 1. And that's equal to, I'm going to go ahead and factor out a negative 1. So it's negative square root of 15 plus 1 over 1 minus times and minus is plus square root of 15. Okay, it's probably going to be easier. I'm going to come up here now. I'm going to rewrite one of these. It doesn't matter which one. I guess I'll write this one. So negative, I'm just rewriting it. 1 plus square root of 15 in different order using the commutative property, and over 1 plus. This should actually be plus here, so this should be a minus, and this is a minus square root of 15. Okay, now I'm going to rationalize the denominators, the denominator, there's only one, by multiplying by the conjugate, which is exactly the same numbers, except it's opposite sign. And so we end up with the negative, and then we're going to multiply. 1 plus 2 times the square root of 15 plus 15 over 1 minus 15. Okay, so I'm going to simplify that a little bit further and get negative in parentheses. We have 16 plus 2 times the square root of 15 over negative 14. Okay, so we've got a lot of 2's here. I'm going to go ahead and factor out 2. So I'm going to take a 2 out of here. So negative 2 times 8 plus the square root of 15 over negative 14. And then we can cancel. This goes once. This is 7. Final answer. 8 plus the square root of 15 over 7. You're done. Get started on your homework. I'll see you next class.